In this lesson, we're going to look at a few additional methods of the turtle class, and these methods can be quite useful under certain circumstances. Let's start with a fresh Python shell, and so that means that I have to go ahead and import the CTurtle module and then go ahead and create a turtle, and let's just call the turtle this time myT. So myT will be a reference to, and then in the turtle module we'll call the turtle constructor, and now myT is a reference to a turtle, and as usual the window has appeared. Now the first method we're going to look at is a method that will draw a complete circle, and so as you might expect, that method is called circle. It needs one piece of information to do its work. It needs the size of the circle, and so I can say let's draw a circle of size 20, and if I execute that method we can see that the turtle has, from its starting position, made a complete circle and come back to the exact location where it left off. And I can go ahead and ask it to make a larger circle, 5 times larger I guess in this case, and it will do the same thing. And as we would expect, the circles are beginning and ending with the current position of the turtle. Another method that can be quite useful that's similar to circle is a method called dot. And dot can be used for plotting or for representing a particular location in the turtle world. And so to see this, let's go ahead and move the turtle, and when I move the turtle, what I'm first going to do is lift up the tail so that I don't leave any lines behind. Now let's go forward, say 100 units. Now we're going to tell the turtle to perform its dot method. The dot method again takes one piece of information. It takes the size of the dot. Instead of creating a circle, what it's going to do is create a filled in dot. And so let's create a dot of size 5. So when I do that, what we'll see is that the turtle now, at the position of the current tail, has left a dot. If I move the turtle forward, and remember that the tail is currently up, we can see that the dot is left behind. So those are two very useful methods for creating circles or creating dots that can be used in a sense to create pre-programmed kind of geometric forms, or if you're creating a graph of some kind. The final group of methods that we want to look at are methods that are used for coloring regions of our drawing. And there is what is referred to as the fill color. And the way that the turtle works is that if you tell it to begin filling a region, it will keep track of that region, and at the point where you tell it to end the filling, it will then completely color from start to finish that closed region. This is much easier seen with an example. The first thing we have to be careful to do is to make sure that we set what's called the fill color. The reason for this is because the default fill color is going to be the background color and we won't see anything. So let's create a fill color, and let's set the fill color to red. Now realize that even though the fill color is red, the tail is still black. We haven't changed the tail color. So any lines that are drawn will be black, but when we fill in a region, it's going to be filled in as red. Second thing we need to do then is to tell the turtle to start filling. And so the way we do that is we use a method called begin fill. Now this method doesn't need anything to do its work, but it is important to notice that this method has an underscore, begin underscore fill. When we execute that method, we won't see anything happen, but what it tells the turtle is to begin remembering the region that is being traced out in the future commands. So now let's go ahead and just move the turtle, and the first thing I'm going to do is put the turtle's tail down, and now let's move forward, say 100 units. Notice that the line that it makes is black even though the fill color is red. We haven't filled anything yet. Let's go ahead and turn the turtle to the left 90 degrees. let's move forward, say 150 units. Let's turn the turtle again to the left, this time maybe 45 degrees, and then let's go ahead and go forward, this time maybe 50 units. So at that point you can see we've gone forward, turned left, gone forward, turned left 45 degrees, gone forward. And remember that at this point, at the start of this, we began keeping track of the filling region. So what you could imagine now is that from that point to the current location of the turtle, we have, in a sense, created a region between the beginning and this ending point that we could fill in if we told the turtle that this was the end of the filling region. And so the way that we do that is we simply use the corresponding method endFill. Endfill doesn't need any information to do its work, but what will happen now when I execute this method is that that region, as we just described, will now be filled in using the fill color. Notice that it's not necessary to close the form. I didn't have to drive the turtle back to the starting point. It will automatically use the beginning fill point and the ending fill point and try its best to find the region. Now, most of the time you might very well create a region by moving the turtle and closing it yourself, but that's not necessary. The final thing that we want to talk about is sort of a mechanical element of the turtle, and that is that whenever we use the turtle, oftentimes when we run a program, what we want to do is make sure that that program executes and then we can see the result on the screen. And so the way that we do that is, as the very last thing in the program, we are going to tell the window to, in a sense, freeze until we release it. And the method that we use for that is called exit on click. And so if I invoke myt.exit, and it's a capital O and a capital C, again, it needs nothing to do its work, but what's going to happen here is that the window is going to disappear when I click on it. In a sense, the window is going to close. Now, this might be better seen if I were to run this program from idle. And so let's go ahead and close out of the Python shell, and instead let's go ahead and start up idle. And now what I've done is to create a program very similar to the one that we had before, and I've already stored this program, so all we have to do is open it. And I used the idle editor. I called the program part3.py. And so here's the program. It imports the turtle, it creates a turtle object, creates some circles, creates a dot, and then does the work of creating the region. And notice the very last line is to call exit on click. So when I run this program, what we're going to see is that the turtle window appears and it freezes. Now this turtle window, in a sense, is sitting here waiting for me to release it. And when I release it, by clicking on it, it will exit, and notice that that brings us back to the shell, and now the program has finished executing. Now, of course, our idle window is still here, and we could go ahead and run that module again, and as we would expect, the window reappears. It does what it's supposed to do. When we click on the window releases, it goes away, and now we're back and we can continue to do that, make changes, and so on.